All right, so each of you has the same piece, approximately the same piece of cardboard to work with, and each of you cut off a different amount on the square. And Nate's group, which is this figure right here, this figure is supposed to hold the most volume of all four figures. Okay. What we're doing with what we're covering today is we're taking a project like this, but instead of doing separate ones and then looking and see what we got, we want to use calculus to figure out what do I need to cut out to make the figure that will hold the most volume. Okay, and it looks like it needs to be between what and what. It looks like it's got to be between 1 and 1.5 or 1.5 and 2. Because what can happen after 1.5? It could increase before it comes back down to 32 inches cubed. Okay? So it looks like the dimension I need is somewhere between 1 and 1.5 or 1.5 and 2. So now we want to use calculus to figure out what this needs to be. So whoops, that didn't work very good, did it? So what do you think we can do to use calculus? Because we're wanting to do what with our volume? We're wanting to get, what's the word I'm looking for?
Maximum.
We want a maximum volume. And that should be a key word in calculus. If I want to get a maximum, what do I have to do? Take the derivative and
Find where it changes
from
positive to negative.
find where my derivative changes from positive to negative. But in order to take derivative, what do I need first?
Equation.
I need an equation. So what is it I want to maximize? I want to maximize volume. So I need a volume equation for this figure. So what is my volume equation for this figure? Volume equals length times width times height. But this one is a special one. Why is it special?
All the sides are the same.
Which means what are the same?
So,
As far as my variables go up there.
as
The length and width are going to be the same. So that means I can change the L into a W or the W into an L. So I'm going to do the W into an L. So that means I'm really dealing with L squared and H. Yes?
Why wouldn't the height be the
Because the height depends on what I'm cutting out here. Okay? Let me see what color I need. These distances right here, that's going to be a length and that's going to be a width. And those distances should be the same. So that's why the length and the width are the same. But the height, which is this distance, is what's changing. That's what each of you did differently. Okay? But I don't want to take the derivative of this just yet. And why?
Because you have three variables.
I've got three variables. So what does that mean I need?
set the relation between two.
I need something else that will allow me to substitute from one to the other. So let's go back to this figure. What information do I know from this figure to be able to set up another equation that's going to let me isolate one of my variables?
The dimensions of them. Now the length was in our case 6, and the height was 1.
All right, well, you're close. So let's say, I know that's a L, and what is this distance right here going to be? That distance is going to be an H. So I know the distance from here to here is H, the distance from here to here is L, and the different distance from there to there is H. Right? So what equation can I set up with that information right there?
S equals L plus 2H.
There you go. What'd you say, Roshan?
S equals 2H plus L.
How about 8 equals 2H plus L? Does that make sense? So I've got my height pieces on the end, I've got an L in the middle. All three of those have to add up to 8 inches, correct? So now, what's easier to solve for here, H or L? L. So I get 8 minus 2h equals L. Well, I have now isolated the variable, so what do I want to do now? Plug in back into the other equation. So I'm going to get 8 minus 2h squared times h. So now I've got that one ready to do what? Take the derivative. So what's the derivative of v?
dv over dt.
dv over dt, but we're not doing anything with time, so I can just call it v prime. Okay? If I'm not doing anything with time, I don't need the dv over dt or the dl over dt or the dh over dt. I can just take the derivative. All right, so what am I going to do to take the derivative over here?
Chain rule.
Chain rule and product rule. So I need the first times the derivative of the second, which is 1, and then plus the second times the derivative of the first. Which gives me that. And Prashant, anytime we do the product rule or quotient rule, what do we always want to look for? What you can take out. What can I take out here? 8 minus 2h. So if I do that, that means this is gone, and I'm left with an 8 minus 2h over here. That's gone, and I'm left with a minus 4h, correct? So that cleans up just a little bit more. So there's my derivative. So Hunter, what do I want to do with my derivative now? Yeah, you do. You just don't know you do. What'd you say?
7 equals
Set it equal to 0.
That's right.
So that gets 8 minus 2h equals 0. So that means 8 equals 2h, which means h equals 4. The other one is 0 equals 8 minus 6h. So 6h equals 8, and x equals 8 over 6. Now what do I want to do next? I don't know why. I don't know why I did x over here. There you go. What'd you say? You want to do a sine line. So I've got 8 over 6, and I've got 4. And what do I know about my sines?
They should alternate.
They will alternate. So what's an easy number to pick?
0.
I don't want to pick 0. Why do I not want to pick 0? What does h represent?
Height.
The height. Do I want my height to be 0?
No.
No. So let's don't pick 0. So let's pick 1. So if I pick 1, this first one is positive. The second one is positive. So I'm positive here, negative, and positive. And what is it I'm looking for? I want the not concavity.
Just kidding.
I want a maximum, which is where the derivative changes from positive to negative. So my maximum is going to occur right here at 8, 6. So in order to produce the largest volume, the amount I need to cut out from each corner should be 8 over 6. Or, yes, 1 and what is it? 1 and a third. So, let's find the volume to make sure it's bigger than the other volumes I found. So what do I want to do to find the volume now? Plug in 8 over 6. And I can plug it back in right there. Okay, so let's plug 8 over 6 in. Alright, so I have 8 minus, that's going to be 8 over 6, so that's going to be 8 over 3. And square that, and then 8 over 6. Somebody that has a calculator, punch that in real quick. And let's see what we get.
Does anyone have 128 over 9?
Give me a decimal.
14.2.
That's not right. Did you square it? Let's put a square in there somewhere.
Send it back to me.
No.
Okay.
No, the
That's-
2, yeah, 2 is
37.9.
There we go. 37 point what?
I didn't
925.
put the carrot, I just put it.
926. All right, what are my units? Inches cubed. Is that volume bigger than any volume we put up on the board earlier?
Yeah.
Yes. That is the maximum volume. When I create a figure like we did, that's the maximum volume I'm going to be able to get out of that figure. Pretty cool, huh? Really cool. So, let's go back and talk about some things because we need to identify some of these equations. What did I do to this volume equation? What did we eventually do to it?
Found the derivative.
We found the derivative of it. Why do I want to find the derivative of the volume equation?
So you can find the maximum.
Because I wanted to find the maximum what? Volume. Whatever you want to find the maximum or minimum of, that's what you want to take the derivative of. Okay? So whatever you want to take the derivative of is going to be called your primary equation. So whatever you want to maximize or minimize and whatever you want to take the derivative of, that is your primary equation. So what are we going to call this other equation? Secondary. The other equation is your secondary. What do we use the secondary equation to do?
Find the derivative.
Eliminate a variable.
Eliminate a variable. We use the second derivative or the secondary equation to help us eliminate a variable. Once I do that and I eliminate my variable and plug it back in, then what do we do? Took the derivative, found my value, set it equal to 0, found my values, put it on the sign line, and then found, in this case I wanted a maximum, so I was looking for a maximum, or I could find the minimum.
Is there ever going to be more than one maximum or minimum?
No. If you're doing one of these, there's only going to be one. Now, let's talk about 4 real quick. Do I want my h to be 4?
No.
No. Why can h not be 4? Because how many h's are there? There's 2. And if both of these h's are 4, what does that make it?
Which is not 0.
0. So I can't get a volume. So actually, in this case, it should have been from 0 to 4 was my only possible interval that I could have been able to find anything in. So once I found h6 in this case, I knew that was going to be my answer, even though we need to go ahead and do the sign line. Okay? All right, let's try another one. Here's my worksheet for the day. Okay, we're going to look at number 1 on this. All right, number 1 says, find 2 numbers whose sum is 10, for which the sum of their squares is a minimum. Find 2 numbers whose sum is 10, for which the sum of their squares is a minimum. So what should we try to find first?
And the primary.
I would try to find the primary. How do we identify the primary? No. How do we find the primary? What do we want to do to the primary? Take the derivative. How do I know I want to take the derivative of the primary? Read this question again. Find 2 numbers whose sum is 10, for which the sum of their squares is a minimum. Minimum. Whatever I want to take find the minimum or maximum of, that is my primary. So it says for which their sum of the squares is a minimum. So what is my minimum equation?
Like x plus y equals 10. No? I have no idea.
Sum of their squares is a minimum.
X squared plus Y squared equals 10.
Okay, I would do the sum equals x squared plus y squared, because I don't know what their sum is. So my sum is going to be x squared plus y squared. So now let's go to the secondary. It says two numbers whose sum is 10. So what's my secondary?
X plus Y equals 10.
X plus y equals 10. Any questions on those two formulas? Okay, which one do I want to take the derivative of? The primary. So what am I going to do with my secondary? Eliminate a variable or get a variable by itself. So in this case, it doesn't make a difference. So let's get x by itself. So that means x equals 10 minus y. Now what?
Plug 10 minus y in for x.
Plug 10 minus y in for x. Okay, so s equals 10 minus y squared plus y squared. Now what?
Derivative.
Derivative, good. So s prime equals 2, 10 minus y, don't forget about the negative on the inside, plus 2y. Now what? Set it equal to 0. So I'm going to clean this up a little bit. That's 20, or actually negative 20 plus 2y plus 2y. So that is 20 equals 4y. So y equals 5.
You wait, you didn't just ignore it.
Now what? Sign line? Are my signs going to change?
Yeah.
Yes. What's the number just to the left of 5? 4. So this. If I simplify it, that's my derivative. So if I plug 4 in, that's negative 20 plus 4y. So is that going to be positive or negative? It's going to be negative, which means that's positive. What is it I'm looking for? Minimum. So my minimums are going to occur when what? When y equals 5. But the directions say find two numbers. So what do I need to do to get my other number? Plug that back in. Now, when you plug in to get another number, where do you always plug into? Secondary. You always get it from the secondary. So I'm going to plug 5 in here. What does x end up being? X ends up being 5. So two numbers that add to 10, and their sum of their squares is a minimum. My two numbers have to be 5 and 5. Okay? So, if I'm going to find a maximum or minimum, an optimization problem, what do I want to identify first?
Primary.
I want to identify my primary equation. Then I want to get a secondary equation. Then I want to
Primary
Replace.
use the secondary equation to replace the variable in the primary. Then what? Take the derivative, set it equal to 0, do your sign line, figure out whether or not you're max or min, and then make sure you answer the question. Now, sometimes there is just a primary equation and there are only two variables in it. If you get a primary equation that only has two variables in it, what do you not need?
Secondary.
You do not need a secondary. So sometimes there's optimization problems that don't need a secondary equation. So keep that in mind. Alright, I want 4 problems on this worksheet. I want number 2, 4, 5, and 7. 2, 4, 5, and 7 are what I want done when you get to me tomorrow. And then we'll